Welcome to the Build 3D Importing series. In this session, I will show you how to create 3D geometry based on your Leapfrog geological model by importing surface meshes through the Sequent cloud-based collaboration tool, Central, into Build 3D. This workflow is useful for simulating a three-dimensional analysis based on your Leapfrog geological model. This includes the use of a transformation tool in Build 3D, which can be used to save the transformation settings of your imported surface meshes to reduce time spent on future importing from the same coordinate system. For example, you may want to understand the three-dimensional pore water pressure system of your geological model prior to generating 2D sections for use in Slope W, allowing you to simulate the slope stability of your Leapfrog project using pore water pressure data. In this video, I will step you through the basic steps of importing your surface meshes from your Leapfrog geological model into Build 3D. We will start in Leapfrog Works. Although surface meshes may be imported from any Leapfrog geological model that uses mesh-based surfaces in the surface chronology. Here we can see that we have 5 layers with 4 surface meshes representing the lithology contacts. We also have a topography surface that was defined using topographic points and represents the upper boundary of the geological model. Since we are connected to Central, we can publish this Leapfrog Works project to our Central portal for sharing with other Sequent users. Now, let's open a GeoStudio Seep 3D analysis to bring in our riverbank geological model from Leapfrog Works. Note, we are signed into our Sequent ID license, which allows us to use the Import Background from Central feature. Upon opening the Import window, the Select Central server will automatically open. If you have access to a Central portal, the server will be listed in the Central Server dropdown. Next, we must choose which Central project we would like to import our background meshes from. I will choose the Leapfrog to Seep 3D project that I had open in Leapfrog Works, along with the desired branch, ID, and geological model. After hitting OK, Build 3D will begin to process the background meshes. You can see the uploading progress on the Task Manager bar along the bottom of the Build 3D window. Once the files are fully loaded into Build 3D, you can choose to import all surface meshes associated with the selected geological model, or you can import only selected meshes from the list box. I will choose to import all meshes from my geological model. You will notice that the surfaces are all rotated. Leapfrog products use the Z coordinate to represent elevation. Build 3D, however, uses the Y coordinate to represent elevation. This means that we will need to transform our surface meshes so that they use Build 3D's coordinate system. The transformation section of the Import Background tab can be used to remap the axes so that the Z coordinates in the Leapfrog files are imported as Y coordinates in Build 3D. We will transform the Leapfrog X coordinates to Z coordinates in Build 3D, as well as the Leapfrog Y coordinates to X coordinates in Build 3D. Next, we will need to modify our base point coordinates back to 0 so that we can review the new geometry extents of our Leapfrog surface meshes with our remapped axes. Once the base point coordinates are set to 0, we can review the minimum extents in the Properties window to help us determine our desired base point of our Leapfrog coordinate system that we would like to import to our local coordinate insertion point. I will add coordinates that are near the minimum extents and keep my insertion point at the local origin of 0 in all directions in Build 3D. The insertion point refers to the local coordinates in Build 3D that the base points will be translated to. This point is represented on the drawing by the axis origin arrows. Now that our surface meshes have been transformed to my desired local coordinate system in Build 3D, I will save my transformation so that I can use it again on further surface importing from Leapfrog. Alternatively, I can use the reverse of my transformation settings if I decide to export a surface geometry back to Leapfrog Works from GeoStudio. Once you are happy with your imported surface meshes, you can click OK. The surface meshes will automatically be added to the design tree under the Background Meshes group. I can right-click on the parent node of the background meshes to edit the import settings, or reload the surface meshes from the chosen Leapfrog geological model. I can also choose to turn off the visibility of the surface meshes to view only one at a time. In order to convert my background mesh into a NURBS surface for my 3D geometry, I will right-click on the surface mesh for my topography and choose Fit to Surface. The Fit to Surface feature, along with material and boundary condition associations and mesh generation, will be covered in subsequent tutorials.